In this video, we're going to have a look at how we calculate with numbers in index form. So just as a reminder, index form is when we have a base number. For example, we're going to have a look at a base of 2, and then we have the index, or our power. So we could have the power of 3. So we can see that when we have 2 to the power of 3 is in index form, we can expand that to 2 times 2 times 2. So it's the base number 2 multiplied by itself 3 times. So that means 2 to the power of 5 is 2 multiplied by itself 5 times. And yes, we can then actually evaluate this as 32. So we have index form, expanded form, and then its value. So we're going to take a look at what happens when we want to multiply numbers that are in index form, so involving indices. So we've got a question here, 2 to the power of 3 multiplied by 2 to the power of 5. What is this equal to? So let's see if we can simplify this a bit. So if we expand what we're seeing here, 2 to the power of 3 is the same as 2 times 2 times 2 multiplied by 2 to the power of 5. So that is 2 5 times. There we go. So when we have a look at this long string of 2's multiplied together, we think, hang on, that's actually the same as 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8. So really, 2 to the power of 3 multiplied by 2 to the power of 5 is just 2 to the power of 8. We take a closer look and we think, hang on, we had an index of 3 and an index of 5, and now we've got an index of 8. Does this mean that we just add the indices if we're dealing with the same base of 2, for example? Let's have another look. We've got 3 to the power of 3 multiplied by 3 to the power of 2. So in expanded form, we've got 3 times 3 times 3 multiplied by 3 squared, so 3 times 3. So yes, really, all we've got here is 3 to the power of 5. Looking back at the indices that we had an index of 3 and an index of 2, and yes, if I add them, I do get an index of 5. So what we've just identified is a really nice rule that when we're multiplying numbers with the same base, we can just add the indices and actually evaluate it in a much simpler way. Well, what about negative numbers? So we've got negative 2 to the power of 2 times negative 2 to the power of 4. Now, if we use our index law, we should just be able to add the indices, 2 and 4. So this should be negative 2 to the power of 6, because they're the same base. So let's expand it. So we've got negative 2 times negative 2, to negative 2 squared, multiplied by negative 2 times negative 2 times negative 2 times negative 2. In fact, we do have negative 2 multiplied by itself 6 times. So yes, it works. So what happens now if we want to deal with situations where we're dividing in index form? So as a reminder, 3 to the power of 5 is just 3 multiplied by itself 5 times, and 3 squared is 3 times 3. So let's pretend we've got 3 to the power of 5 divided by 3 to the power of 2. Now I'm going to write this as a fraction because the fraction line means divide, and it's much easier to work out. So visually, if we expand this, we've got 3 times 3 times 3 times 3 times 3 on top of our fraction, and at the bottom we've got 3 times 3. Now because we know that timesing by 3 and dividing by 3 actually cancels each other out, because we all know that 3 divided by 3 is the same as just 1, we can cancel that down to 1, and we can do it 2 times because we've got another 3 divided by 3, and they kind of undo each other. They get us a value of 1. So essentially all we've got left here is 3 times 3 times 3 in the numerator, which is just 3 to the power of 3. Think, hang on, we had an index of 5 and an index of 2, and we've divided and we've ended up with an index of 3. Gee, that seems as though we've just subtracted the indices. So let's try it with our next example. We've got 4 to the power of 6 divided by 4 to the power of 5. So if we expand it, we've got 6 4s together, all divided by, 5 of these 4s multiplied together. So now again, multiplying by 4 is the same as dividing by 4. We get a value of 1. Multiply by 4, divide by 4. Multiply by 4, divide by 4. And multiply by 4, divide by 4. So essentially, what we've got left is 4 times 4, I've got one more to cancel. We've got a 4 at the top and just a value of 1 at the bottom, which just leaves 4 to the power of 1. So taking a look at our indices, we've got an index of 6 and an index of 5, and we ended up with an index of 1. So that tells me that we subtracted the indices to end up with a power of 1. So is this that when we're dividing with the same base, we're actually going to subtract the indices? Well, let's have a look at one more. 7 to the power of 5 divided by 7 to the power of 3. Now my index law tells me that I'm just going to subtract the indices and get 7 to the power of 2. So if we expand this, let's have a look. Okay, let's do some cancelling. 7 divided by 7 is 1. 7 divided by 7 is 1. And 7 divided by 7 is 1. And we are right. We are just left with 7 times 7, which is 7 squared. So when we're dividing with the same base, we can just subtract those powers or those indices to simplify our answer. So let's have a look at some more examples. So we're trying to identify the same base, and if we can find values with the same base, we can put them together and simplify them. So here I've got 6 squared multiplied by 6 cubed and multiplied by 5 squared. Can't include the 5 squared because it's got a different base, but I can multiply the ones with the same base, the 6's. And I know when I multiply, I can add the indices. So 2 plus 3 is 5, and we can't forget what is still part of our calculation. So I've just simplified that one by putting the bases of 6 together. In our second example, we've got negative 2 all to the power of 3 times negative 2 all to the power of 2 divided by 3 squared. So I know that these ones have the same base and we're multiplying, which means I can add the indices. So I've got negative 2 to the power of 5 divided by 3 squared. These numbers have a different base, so I can't put them together. In my third example, I'm dividing, and I know that when I'm dividing with the same base of 6, I can subtract the indices. So my answer will simplify to 6 to the power of 4. And in my last example, we've got 4 to the power of 5 times 7 to the power of 3, all divided by 4 to the power of 1 times 7 to the power of 2. So here, because I'm multiplying, I can just group the bases that are the same and deal with them separately. So 4 to the power of 5 divided by 4 to the power of 1. I know that's just going to be 5 take 1, because when we divide we take the indices. So that's going to leave me with 4 to the power of 4, and that's times by 7 to the power of 3 divided by 7 squared. So that means I can subtract the indices and I'm left with 7 to the power of 1. And I don't need to write that index of 1. I can just leave it as 4 to the power of 4 times 7. So now it's your turn. Have a look at the following 5 questions. Have a go at them, show your working, write your answers into your workbook, and please bring it to our next lesson.